Lesson 3.2, Functions. Now we're going to increase our vocabulary again and talking and going further than just relations and just asking ourselves, is something a function and how do we use functions? By definition, a function is a relation in which there is only one value of the independent variable for each value of the independent variable. Now the key to this whole phrase is only one. This is also described as a one-to-one relationship. One x value goes to one y value. So again, dependent meaning x, dependent meaning y. And we'll see what that looks like in a moment. Vertical line test is a way to see that visually, that definition visually. And vertical line test is a method of determining whether a relation is a function. So you use this test to decide if what you have is a function or not, given a graph, of course. It is a function if no vertical line intersects the graph at more than one point. And again, I will show you an example of that in a moment. Functional notation is a huge leap forward for us. Now, before I even uncover this piece, let's review one thing. If I had given you an equation in the past, it would have looked something like this. Now, this is an equation, but it is not in functional notation. Functional notation will take this part, and instead of saying y, it'll use a letter. Lots of times it's f, and it will give you a parentheses, and it'll have an x inside it. And then the rest of it is the same. So notice that the only piece that changed was where the y was. Now this is important because this does not mean f times x. It is described as f of x. And it describes a couple things. It tells the reader what's going to be plugged into the equation, and it also gives it a label, in this case f. And I could say g or h and so on, that is arbitrary, but it describes a function and puts a label on it per se. So I could actually give you another one, and I would say g of x equals 3x plus 2. Now this is another function, another equation, but I can say to the reader, okay, I want you to work with the function g of x, or I want you to work with the function f of x. Whereas before, if I just had y equals, I was kind of limited in my description. They are both set equal to y, so now we have a better way of describing something, an improvement in our vocabulary and our description abilities. But that also carries over to an XY chart. We would not just do an XY chart. We would still do an XY chart, but the Y part would be written, instead of Y, it would be like f of x. Okay, and I'll show you what that means again in a moment. So I wanted to preface this box by stating that. So here's an example again. A way to name a function that is described by an equation. So we used to say y equals 3x minus 2. It's now rewritten with the f of x. And again, it's stated as f of x. And this is pretty nice here. It means f of 1. In other words, this notation tells you, the reader, that they're plugging a 1 into the equation. So again, mainly for description purposes. So here's a nice little visual. Very familiar with the table. Here's the equation with the new change, and I would have liked this to say f of x instead, since we're using functional notation. And then we would have our graph on the right. So just a couple of changes here, and this is the main one in the middle. So is something a function or not? Well, here is where we work with the vertical line test. So I have this vertical line, and I know that something is a function if there's no part of the graph hitting my vertical line in more than one place at one time. So I have a red graph, a parabola, sideways parabola that represents the function x equals 1/3 y squared minus 2y plus 5. Now, as I move this vertical line to the right there it hits the graph at one point, but all of a sudden if I go further, I have a problem. My vertical line intersects the graph in this position and in this position. Because it intersects the graph in more than one place at one time, we would say that this is not a function. Let's try the next one. If I take this vertical line and pass it over this one, okay, now notice I'm passing over the red, but I'm only intersecting it at one point. I got a very thick line here, sorry about that. Actually, I wonder if I can modify that. Go really narrow. There we go. Now it's just intersecting the red line at one point at a time. So if I move it, I'm still intersecting only at one point at a time, so it passes the vertical line test. So this one is a function. Now the next one has a list of ordered pairs. Now, if I were to graph it, so if I can make this smaller, we'll see here. Alright, I want to get rid of that, it's not helping me any. Alright, I want to draw it by hand. If I were to graph it, 1, -4 is down here somewhere. 2, -4 is down here somewhere. And 6, -4 is over here somewhere. Now again, vertical line test. Do I pass vertical line test? Well, if there's no points right above another, it's a function. That point's there. Now there's points to the left and right of each other, but none exactly above each other. So this one is a function. In other words, our y's can be the same, but our x's cannot be the same. So let's go to our last example. Again, this is a table of ordered pairs, so if I put them in ordered pair notation, again I'm using my mouse, I apologize for the bad writing here. 5 and 9. I'm just trying to make it look a little bit like C. Notice that this one, these two here have the same x values. So if I graph it, I have -2, 2, I have 0, -1, I have 5, 9, and 5, 6. This one would definitely not pass a vertical line test right there. On a graph, that's what it would look like. On a table, whenever we have the same x value going to a different y value, we would say is not a function. It does not have one x value going to only one y value. So this one is not a function. Alright, now let's go through these. I have 6 examples of what it means to plug in a function. Now f of 2 means to plug a 2 into the x position. So I type these out because my mouse is not writing very easily. So f of 2 means plug a 2 in wherever the x was. So I get 3 times 2 minus 4. 3 times 2 is 6, minus 4 is 2. There's our answer. So if you plug a 2 in, you get a 2. G of 5 is basically telling us plug a 5 into the x positions. Wherever there's an x, plug it in. And that means we'll take 5 squared plus 2 times 5. All the x's are replaced with a 5, which means 25 plus 10, which is 35. Negative 8.9 gets put in there. Plug in negative 8.9 where the t is, and we get negative 8.9 plus 2.1, which gives us negative 6.8 in the absolute value symbol, and therefore it changes it to positive. So again, this would be very much like an XY table if I go back to what it used to be, and it says plug in a 2, and when we plugged in a 2, we got a 2 out. So we're just looking at it in a little bit different way. Same thing here. This one says, now this one's more interesting. It tells us to find out what g of 3 is and then subtract 1. So g of 3 would be to plug 3 into those places. I'm just finding g of 3 first, and I get 3 cubed minus 3. Again, I'm focusing on the left piece here. That means 27 minus 3, which gives us 24. Now it says it wants g of 3 minus 1. Well, g of 3 is 24. Now I'm supposed to subtract 1 from it. So the answer is 23. Now what's interesting about this is you can start to look at this in a goofy way here, but it is algebra. S of a, it's not a 5. It has s of t equals 7t plus 6. It says to plug an a in. So we used to be plugging numbers in, now we're plugging in a letter. Well, you can do that, and look what happens. The t gets replaced with an a, so we end up with just 7a plus 6. All that happened was the letter in the parentheses changed. No numerical value went in, so nothing changed. We couldn't actually calculate it. Now this is what's really fun. F of 2c minus 3. Now we're going to plug in all of that into that position. Now what's that look like? Well, the n gets replaced with all of that, so it's substitution. We substitute in 2c minus 3, so then it becomes a distribution question. We distribute, and we get 8c minus 12. And this is kind of where the fun begins in terms of algebra and Algebra 2 trig. What does it mean to use functional notation? What's its purpose? And what are its positives? And then when we get control of the new notation, we can start to do and plug in many, many different kinds of things besides just numbers. And this should be somewhat familiar with what we did the first week of school with plugging in numbers. And this ends lesson 3.2.